Systems of equations in a nutshell. A system of equation is essentially just two or more equations that can be represented in a bunch of different ways. And recognizing what forms they're in really helps you decide which methods would be quickest. And imagine each of these equations is a set of lines, and where those two lines intersect is the solution of the system of equations. The three methods most frequently taught: graphing, substitution, and elimination. Graphing is usually the quickest if both of your equations have y isolated. For example, if you had these two equations, both have y equals all by itself, which means we could plug this into a calculator and find where the two lines cross each other. If you're allowed to use Desmos, you only have to type in the part after the equal sign. Make sure when you have a fraction, you tap back out of the bottom of the fraction before you put your x. Once you put the 2 points in, find the point where they intersect, and there's your answer. -6, -8 in this case. Normally the answer is written as an ordered pair with the x and then the y in parentheses. The downfall of graphing is that if you're not allowed to use the calculator, it can take some time, and a lot of people have issues with graphing, which then leads us to substitution. A lot of times textbooks will use formulas like these, standard form and slope-intercept form, as examples of when substitution is a good option. But ultimately, you're looking for one equation where you have a variable by itself and another equation where you have a combo of both variables on the same side of the equal sign. This is what these formulas would look like with numbers in them. Standard form has x and y on the same side of the equal sign. The key to substitution is when you have that one variable by itself, in this case y. We could take everything that the y equals and substitute it, replace it for that variable in the other equation, which would mean we're taking this -3x plus 8 and putting it into this first equation for the y. So we would take that first equation, rewrite it, but instead of the y, we would put open parentheses, and in those parentheses, we would put that equation. Don't forget to finish writing the last bit of the equation. So once you have substituted one of your equations into the other, your whole new equation should only have one variable in it, which means we can start to solve for x. So first, take that -3 and distribute it in. Some people might find it helpful to block off this equal sign in order to keep the two sides of your equation separated. These two x's are on the same side, so we can combine them. Add 24 to each side to cancel, then divide by 13 to finish isolating x. And we get x equals 3. Now remember, a rule for systems is we need an x and a y. Right now we only have half of the answer. Thankfully, we're only a few steps away from finding the y. But as you can see, this is taking quite a few steps. So if you have the opportunity to use a graphing calculator like Desmos, this may be the faster method for you. So to finish our solution, we would take what we just found for x and go back into this second equation here and plug it in. Because y is already by itself, if we substitute x on the right, we only have to solve this side, and that will give us the rest of our answer. So here I've just rewritten that second equation, and we're going to replace this x with the answer that we found. And now follow your order operations and solve for y. -3 times 3 is -9, and -9 plus 8 is -1. So if we take our two answers and put them together as a point, we get 3 -1 as our answer. While substitution is pretty algebra intensive, it's probably the strongest skill of all to have, as it can be used in many different situations. Elimination, however, has very particular cases where it can be used, but can often result in a very fast solution. And elimination is usually best when both equations are in standard form, with the variables on the same side of the equal sign. Let's work out this example to see. Again, recognize both equations have x and y on the same side of the equal sign, and the way elimination works is we will combine these two equations, working downward. So making sure your variables and equal sign are stacked together is key. I find it's helpful to add a plus sign in front of any positive numbers where there isn't a sign already. The key thing with elimination is recognizing when one variable has the same number in front, but with opposite signs. Because in this case, when -2 and +2 will combine, they'll make 0, and our y's will cancel out entirely. And now when we combine these equations, we're just going to follow the signs. +4 plus 2 gives us 6x. Our y's have canceled out, and that's going to be equal to +9 plus 3, which is 12. And now we're one step away from solving for x. Divide both sides by 6 to finish canceling, and we get x equals 2. Now again, this is only x, so we still need to solve for y. In this case, we could pick either of the two equations, plug in our x, and then isolate the y. I'm going to pick the second one in this case. So here's that second equation rewritten. We're going to take that x and substitute in this 2 that we solved for. And now we have an equation with only one variable in it, so we can start to solve. 2 times 2 is 4. It's a +4, so we need to subtract from both sides in order to cancel. 3 minus 4 is -1, and since 2 is multiplying, divide both sides by 2 to finish up. So our final answer is when x is 2 and y is -1/2. Combined as an ordered pair, 2, -1/2 would be our point of intersection. And so that's a basic example with each of those methods explained. However, substitution and elimination can get a bit more complicated sometimes, so stick around for more videos with detailed examples of those.